Today we are doing synthetic division, which is a simplified process of the long division that we have already learned. So we are going to be following the same steps, but what we're going to be looking at here are just the coefficients of our dividend and our divisor. So again, we are going to be writing in standard form, descending order. If we have powers that are not there, we're going to put a 0 placeholder there. And then what we're going to be using as our divisor is reversing the sign of the constant in our divisor, and that's going to be our value k. And then again, we're using that same process we did for long division. So this is just a pattern that we're going to follow. So if we have ax to the fourth and so on being divided by x minus k, we are going to take our coefficients of our dividend, and then we're going to switch that sign on k. So k was negative, it becomes positive, and vice versa. And we are just going to divide those coefficients and following that same process of bringing down, subtracting, etc. Okay. So, quick reminder, when you're setting up the synthetic division array, we still have to use that 0 for missing terms, and it cannot be used when our divisor's degree is greater than 1. So if we have like x squared or something, we cannot use synthetic division. So the first thing we're going to do is bring down that first coefficient, and we're going to multiply it by k, then we're going to add b. And we're going to repeat that process over and over again. So let's jump right into an example here. On number 1, we've got 5x cubed minus 6x squared plus 4x minus 1 being divided by x minus 3. So I'm going to write all of those coefficients. I don't need any placeholders here. And k is negative 3, so we're going to divide by the reverse of positive 3. So the first thing I'm going to do is bring down that 5. And then I'm going to multiply 3 by 5, and that gets me 15. Then I'm going to add that negative 6 to the 15, which gives me 9. Then I'm going to again multiply that by k. 9 times 3 is 27. Add that to 4, that gets me 31. Multiply by 3 again, that gets me 93. Add to negative 1, and that gets me 92. And this becomes my remainder. So now what I'm ready to do is fill in these coefficients into 1 less than the degree I started with. So that would be 5x squared plus 9x plus 31 plus my remainder over my dividend, or my divisor, excuse me. Okay. So there is number 1. Okay. Let's go again on number 2. I'm going to pull in all of my coefficients. Here k is positive, so we're going to be dividing by negative 1. Bring down our first term. 1 times negative 1 is negative 1. Add that to 4, I get positive 3. Multiply by negative 1, I get negative 3. Add that to positive 1, I get negative 2. Multiply by negative 1 gets me positive 2. Add that to negative 6, and my remainder is negative 4. So again, starting with 1 power less than I started with, that's going to be x squared plus 3x minus 2 minus 4 over x plus 1. Okay. On to number 3. And k is going to be negative 2. Bring down the 1, negative 2, negative 4, positive 8, negative 6. And my remainder here is 0. So that one is a factor. And it divides in evenly. I'm sorry, didn't realize you couldn't see that. So x squared minus 4 plus 3. So that is my answer. All right, on to number 4. I don't have a power with 3, so we're going to have to put a 0 as a placeholder. All right, 1 times negative 2 is negative 2. Add that to 0, still stays negative 2. Multiply by negative 2 again, I get positive 4. Add that to negative 5, I have negative 1. Multiply by negative 2, I get positive 2. Add that to 4, gets me 6. Multiply by negative 2, that gets me negative 12. And again, this one has a remainder of 0. So our answer is going to be x cubed minus 2x squared minus x plus 6, and I do not have a remainder. Okay, use synthetic division to determine whether or not it's a factor. So when our remainder is 0, that means that our divisor is a factor. So x plus 2 is a factor of this polynomial. So in order to use synthetic division, to determine if it's a factor, we are going to do synthetic division and analyze our remainder. So let's set up our synthetic division here. I don't need any placeholders. I'm doing -1, so k will be +1. Bring down the 3. 3 times 1 is 3. That adds to 13. That adds to 12. Oh, I'm sorry, and that should have been a -12. So our remainder is 0, which means that, yes, it is a factor. Okay, now we're going to use synthetic division and the given factor to completely factor this polynomial. So again, first step, synthetic division, obviously it's in the directions. So get those coefficients in. We're dividing by -1. So 1 times -1 is -1, plus 2 is +1. That gives us -6. All right, and that leaves us with 0. So what we did was we divided out x plus 1. So what we're doing is rewriting x cubed plus 2x squared minus 5x minus 6 as these two polynomials multiplied. So x plus 1 times x squared plus x minus 6. So when it says factor completely, we now have a trinomial here that can also be factored. Numbers that multiply to -6 and add to +1 are +3 and -2. So to completely factor our original dividend, I can do so like this. And so I have 3 binomials multiplied together. All right. Last little piece we're going to look at, just 2 more examples, is the remainder theorem. And that is if we have a polynomial that we do synthetic division on, whatever our remainder is, that's the same as if we had plugged our k value into the function. That tells us what p of a is. Remember, this is function notation. P of x means I'm plugging in some x value to my function. So if we do synthetic division and we say that a is -2, we can check to see that if we plugged p of -2 into our function, it would be equal to our remainder. So let's do synthetic division here. Setting up our coefficients, no placeholders necessary, and we're going to divide by that -2. And so I get a remainder of 18. Now, if I plug in -2 to my function, that's -2 cubed plus 4 times -2 squared minus 8 times -2 minus 6. Sorry, that's getting kind of tight there. But that would be -8 plus 16 minus 6, and that does get us 18. So it is the same. All right, let's check this again on number 8. If a is 3, again, setting up my synthetic division, no placeholders necessary. Don't know why I put the plus sign there. It's not needed. 17 times 3 is 51. 3 times 55 is 165. So my remainder is 168. So let's check that. If I plug 3 into my function here, p of 3, 6 times 3 cubed minus 6 squared plus 4 times 3 plus 3. What that's going to get me is 3 cubed is 27. 27 times 6 is, well, let me type it in my calculator, 162. 3 squared is 9. 4 times 3 is 12 plus 3. So 162 minus 9 plus 12 plus 3 does indeed give us 168. All right, and that will wrap up our notes on synthetic division.